Bismillahirrahmanirrahim. Now we are going to start our next chapter, diode. Diode is a semiconductor device that acts as a one-way switch for electric current. It allows current to flow in only one direction at a time, maybe forward direction, while blocking in the opposite direction, which we refer as a reverse direction. This property makes diode an essential element in various electronic applications. Diode's construction is very simple, typically made of a p-n junction where p-type positive and n-type refer as a negative material meet and a junction is formed. When the positive side, which is anode, is connected to the high voltage, then the negative side, which generally refer as a cathode, the diode conducts electricity. In reverse bias, when the voltage is reversed, the diode prevents current flow except at very high voltage where breakdown may occur. Diodes play a crucial role in modern electronics by controlling the direction of current flow. The mechanism of the diode primarily revolves around its structure, which consists of a p-n junction. At the junction, electrons from the n-type material combine with the hole from the p-type material creating a depletion region. This region is devoid of charge carriers and free charge carrier in much better way and act as an insulator. The depletion region has a built-in electric field due to the fixed charge left behind positive ion in the p-type and negative ion in the n-type. When a positive voltage is applied to the anode side of a p-n junction, and a negative voltage to the negative side, which is cathode side of a p-n junction, the electric field in the depletion region is reduced. Charge carriers, electrons and holes are pushed towards the junction from the battery as power source, allowing this to combine in p-n junction or outside the p-n junction. This leads to current flow through the diode. In reverse bias current, when the polarity is reversed, positive voltage with respect to N side and negative of the P side, the electric field in the depletion region is increased, reasonably increased. In other words, widening it. This prevents charge carriers from crossing the junction and effectively block the current flow. Only a very small current, which we referred as a leakage current, may occur until breakdown voltage is reached. The symbol of diode is a crucial element in electrical schematic and circuit diagram as it visually represents how the diode functions within a circuit. Basic symbol structure is relatively simple as compared to other devices. The standard diode symbol consists of two main components. One is triangle. The triangle points towards the vertical line and it represents the direction of current flow through the diode. It's also indicating that current can only flow from the anode, the triangle side, to the cathode, which is the light side. of a schematic diode diagram. Similarly, the vertical line at the end of the triangle represent the cathode terminal of the diode. It is typically marked with bar or line that indicated that the negative side of a PN junction diode. The depletion region in a diode is a crucial area that forms the junction between the P-type and N-type semiconductor material. Actually, this depletion region controls the properties, electrical response, and many other properties you will study in later slides of a p-n junction diode. We discuss some characteristic of depletion region. Firstly, we give that we have again recalled that p-n junction is formed just when p-type and n-type material are joined together. Electron from the n-type region, which has excesses of electrons, diffuse into the p-type region, which has an excess of holes. This movement of charge carrier lead to the recombination of the electron and hole near the junction, resulting in a region devoid of free charge carrier, as we have already discussed. And this region is referred as a depletion region. And it is the main region where all electrical properties of the diode controlled by this region. Charge distribution. As electrons leave the n-type side, positive charge carrier or positive charge donors ion remain in this region, while holes that enter the n-type side leave behind negative charge acceptance. This creates an electric field, and that electric field acts as a barrier to the further movement of charge carriers. The width of a p-n junction is also important, and the width of a depletion region is influenced by the many factors such as doping level of the p-type and n-type material and the applied voltage across the time. Higher doping level results in a narrow depletion. Some signification of the diode can be classified on the basis of rectification. The depletion region is essentially for the diode's stability to conduct current in only one direction while blocking in the opposite direction. When the forward bias, the depletion region narrow, allowing current to flow. When reverse bias, it widens, prevent current flow. Electric field, the electric field established in the depletion region opposes the movement of charge carrier, which is key to the diode's operation. This field also influences the carrier recombination and generation process. The third one characteristic is capacitance. The depletion region behaves like a capacitor. Its capacitance is influenced by the width of the region and the applied voltage, which is important in high frequency application and in understanding the diode switching behavior.